Okay, here we are back with some Algebra, Chapter 3, Section 6, Translations and Reflections. As Bon Jovi said, buckle up, baby, it's a bumpy ride. This one's a doozy, so I've decided to split it into two parts. We're going to start just looking at just straight up translations and reflections before we go into stretching. So first, a few terms. Family of functions is a group of functions with similar characteristics. The most basic function is called the parent function. So the most basic function in a family of functions is the parent function. And in non-constant linear functions, remember constant linear functions, constant was like y equals 5, which that's just a horizontal line, right? So in non-constant, so anything where it's not y equals 5 or y equals 2 or something like that, the parent function is f of x equals x. Now remember that f of x is just a nickname for y. So y equals x. Okay, that is the parent function of linear functions. Y equals x. A transformation changes the size, shape, position, or orientation of a graph. Now we're first just going to look at some translations. Okay, a translation shifts the graph horizontally or vertically, but does not change size, shape, or orientation. Okay, so it just shifts it. All right, let's look at translations. What happens? This right here, this is y equals x. Or in function notation, we would call it f of x equals x. All right, so that's this function right here. If I take that function, y equals x, and I add, let's say I add 2. Well, right now, y equals x is plus 0, so it goes through the origin. If I do plus 2, now the y-intercept is 2. My slope is still 1 or 1 over 1. So now I have this graph. Okay, so I took f of x and I added 2 to it. So I could write this as y equals f of x plus 2. Notice what happened? We increased the y-intercept and it moved up 2 places. Okay, so if we add to the function, then it moves vertically. Okay, so it moved up. If I was to subtract 2, it would move down. All right, now let's have a look and see what happens if I do something to the x. All right, so y equals f of, and then I'm going to add something. I'll say plus 3. Let's change it up a little. All right, so I'll take the parent function here, y equals, and I'll put x plus 3 when I'm replacing this. Now there's nothing outside, there's just a 1 here. So if I do the distributive property with the 1 times x, 1 times 3, I get y equals x plus 3. So I went from the parent function, y equals x, which is this one, and I now have y equals x plus 3. So I could look at this and say, well, now I can find the y-intercept, or I could say, let's figure out what the x-intercept is. So if I subtract 3 from both sides, find the x-intercept, make this 0. 0 equals x plus 3, and then subtract 3 from each side. The x-intercept is negative 3. Where previously we were at 0, now the x-intercept. Because we changed something about the x, that's why we're investigating the x-intercept, is negative 3. So now the new graph goes through the, there we go, the x-intercept, negative 3. So we moved from the original, we moved left 3. By adding 3, we moved left 3. So this right here, if we add to the x inside before we do the input, then it moves horizontally. All right. Okay, that much for translations, first off. Now let's have a quick look at reflections. Okay, here I have the graph of y equals, and this is 2x plus 1. Okay, 1 is the y-intercept, the slope is 2, up 2 over 1. Okay, now I want to figure out what happens if I negate this entire expression. So remember, this is still y equals f of x, and in this case f of x is, and f of x equals 2x plus 1, right? So if I negate, if I take, well, let's go with red for negating, y equals negative f of x, then I have to take what f of x is, and that's this expression here, and negate the whole thing. So y equals negative, parentheses, 2x plus 1. This is like negative 1, so I have to do distributive property here. And that gives me y equals negative 2x minus 1. So now my y-intercept here is 1, negative 1 right here. And my slope is negative 2, so down 1, 2 over 1, down 2 over 1. All right, my new graph is this one right here. Now, if you look closely, you'll notice that this point reflected up here, this point's from here. So we've reflected this graph in the x-axis. So y equals negative f of x is reflected across x-axis. All right. And finally, y equals f of negative x, so we're negating the input, not the whole function, we're just negating the input. All right, so if we go up here, the only thing that changes is going to be the x. So we'll do y equals 2, and then the x is going to be negative x plus 1. 2 times negative x is negative 2x plus 1. So let's look and see what this one looks like. Plus 1 is my y-intercept. We're going to start there, plus 1. And then negative 2. Down 2 over 1. Down 2 over 1. Now I can graph that. Okay, and that looks like this. Okay, if we look at these, notice at this point, reflected over here. This one reflected over there. This point right here reflected over here. So this is a reflection across reflection across the y-axis. All right. Said we're going to split this lesson up a little bit. I'm going to stop it right here, let you digest this, okay? And we'll look at the rest in the next lesson.